In this video, we're going to take a look at cylinder head service. This is a two-part video, so don't forget to watch part B. So when we are going to disassemble an engine, we have to take all the components off the cylinder head before we remove the cylinder head. So again, referring to the manufacturer's recommendations on how to disassemble the engine. So intake and exhaust manifolds have to come off. Again, these could be a one-piece or two-piece or a three-piece exhaust manifold, and they could be fairly heavy. They could contain a turbocharger. And again, removing the turbocharger before we remove uh, the exhaust manifold, because sometimes we can't get to the bolts until the turbocharger is removed. Once those components are removed, there are some other things that we have to do. We have to ensure that we back off all the valve and injectors before we remove the rocker and rocker shafts. The reason for that is if they're still under load and we undo the bolts, we could bend something. So we want to make sure that we back these off before we do that. Once the rocker arms are removed, keep them in their specific order. Don't mix them up. Don't put them on the bench. Make sure they stay in that order. Then we can remove the push tubes. Same thing with the push tubes. Make sure that we put them back in the order that we took them out of. When we're removing injectors, now there are special tools to remove injectors. We don't want to be prying on the electrical part. So popping the injectors out by using the proper tool, an injector heel bar. In some instances, they use a slide hammer, so it threads into the top of the injector and then it's popped out. When we're removing the cylinder head, we want to back the bolts off in the reverse order that they were tightened. So usually when we're tightening, we start at the center and work our way out. When we're removing them, we start on the outside and work our way towards the center. Now, why do we want to do that? Well, because of the stresses that may be in that cylinder head, we don't want to start in the center. The other thing to pay attention to when removing the cylinder head is manufacturers recommend that the temperature has to be below a certain point before we can remove the cylinder head. If the cylinder head's hot and we remove it, it could distort once it cools down. Most manufacturers also have a recommended lifting device to lift the cylinder head off the engine. And when we take it off, we should be setting it onto blocks so that it's not on a table getting scratched and the machine surface isn't damaged. Now we also want to check for cracks. So when we're inspecting the cylinder head, the injector hole is usually in between all the valves. We want to check it for cracks. Now, what can cause a crack? Well, a couple things. If the injector is being tightened down too tight is one of the most common causes of this cracking. We also want to inspect for how well the valves seal. So by pouring solvent in, we can see if the valves are going to leak. When we're taking a look at the head bolts, now head bolts, depending on the manufacturer, it may recommend that we replace all the cylinder head bolts. But those that don't, we have to clean them. So we'll wash any oil off, we'll wire brush them, and then we'll inspect them. We'll inspect them for thread damage, we'll inspect them for stretching, and we'll inspect them for any corrosion. There are manufacturers that allow you to reuse the head bolts, but what they have is they have a gauge. And if it shows that the bolt is too long, in other words, it's being stretched, it's no good. You have to replace it. When we're removing valves, we have a valve spring compressor. Now this is adjustable, so once you set it for 1, you can remove all the valves on that head. So we're going to compress the spring, we're going to take the keepers out, then we're going to relieve the pressure, which then we can take the spring and the valve out. And again, keep these together as a unit so when we inspect them, if we find something wrong with the keeper, we can identify which valve stem it goes with. I don't recommend using a mechanical etcher to etch the valves, but put them in order as we take them off so we know that they can go back in the same order. Most shops don't do pressure testing on the cylinder heads. It's usually sent out to a shop that does this. But if you do, you're blocking off all of the galleries and then you're going to pressurize the head. Now we want to do this in a tank of hot water because we want the metal to expand properly. So you're going to put the head in the hot water, let it heat up thoroughly, and then we're going to put the compressed air in. And as it expands, any cracks will show up. In some cases, you may have to put a dummy injector in the hold down because of the injector tube that's inside. If we pressure it up without an dummy injector in there, it could blow that injector tube out. When we're inspecting, we want to remove all the plugs. Now, there could be frost plugs or there could be pipe plugs. Why do we want to remove all these? Because we could have some sludge or debris inside the coolant galleries or the oil galleries. And we want to be able to wash this out and make sure that it's not going to go through the system. We're going to wash the cylinder head off, and then we're going to blow it off with compressed air. Now, if we're going to leave it for any period of time, we want to make sure we put oil on these surfaces so they don't rust. So if we have to remove the injector sleeves, there's special tools for removing these injector sleeves, the same as when we're going to install new ones, or special tools. What are we going to inspect for when we remove the sleeves? Well, you're going to have to refer to the service manual of what the manufacturer recommends for the inspection, what passes and what doesn't. Now, if we suspect that there's a crack, there's a couple of things. We can use the dye penetrant or we can use the magnetic particle inspection. Now this here, we have a magnet that goes on either side and we spray this fine powder, and it's not in a liquid form, it's in powder form. And again, because we have a negative and positive polarity on one on each side of the crack, it will attract any of the magnetic particles and the crack will show up. Even though it may not be visible, it will with these magnetic particles. The other thing we want to do is we want to check the block to see if it's got a bow or a twist in it. And we're going to use a straight edge. This is a machined straight edge and a feeler gauge. So we're going to put the machined edge across there. We're going to see if we can get a feeler gauge underneath. And then we're going to refer to the manufacturer specifications, what is allowable for a bow or a twist or a warp in the head. Now, once we've got everything else apart, we want to take these valve guide brushes and we want to clean the valves out so that we can measure them properly. So we're going to take the valve guide brush, we're going to wash it down, and then we're going to take a carbon scraper and make sure, and this just removes the carbon, it doesn't remove any metal. So what is the specifications for the valve guide measurements? Well, we're going to use a small bore gauge and we're going to go down inside and we're going to measure in 3 spots, top, middle, and bottom. And what we're looking for is this valve guide bowel mouthed? In other words, are the top and the bottom measurements larger than the middle? If it is, a couple of things. If it's an integral valve guide, it can be repaired in the block. If it is a replaceable one, we can take it out and put in a new one. So this is what bowel mouthing is. So and this is exaggerated, but as a valve moves up and down, the rocker arm moves it from side to side. And what it'll do is it'll eventually wear the valve guide out. So a couple things we want to inspect. We want to inspect the top of the stem. And again, this is going to be resurfaced. We want to check for any wear. So we're going to measure the valve stem. We're also going to take a look at the valve face. And we want to check for any damage. As you can see on this one here, it's got some damage. So this valve would have to be replaced. So again, we're going to take a look at the stem. We're also going to take a look at where the keeper grooves are. Now, if they're distorted, we don't want to reuse this valve because we could end up losing the keeper and then the valve's going to drop down inside the cylinder. We want to measure across the valve stem to see that it still falls within the specifications. We also want to inspect the valve seat. Now, again, we could have an integral seat, which is part of the head, or we could have an insert. If it's an insert, we want to just take a hammer, a real small one, and just very lightly tap it to see if this insert is loose. If the insert's loose, it has to be replaced. Now, in some cases, it may have deformed the cylinder head and it may not take a new seat, so the cylinder head may have to be replaced. So we also want to take a look. Again, most places send cylinder heads out to be resurfaced and also to have the valves done. But we're going to take a look at what gets done when they redo a valve face. So we have a machine that's going to turn our valve face. Now, again, valve faces come in different degrees, either 30 or 45 degree. So we're going to go through and take a look at how this is done. So on this machine, this valve turns and it goes up against a grinding wheel, and we have a lubricant that goes in so we have a nice fine finish. So when we're taking a look, we want to know whether it's a 30 or 45 degree. And one valve may be 30, like so let's for instance say the intake valve is 30, the exhaust valve may be 45. So don't assume that they're both the same. We want to make sure that we don't put a 30-degree cut on a one that's supposed to be 45 degrees and vice versa. Now, when we put the valve stem in the chuck and turn it on, you'll see a noticeable wobble if the valve is bent. And you'll also notice that on the margin, it's not even. When we're putting in the machine, we also have automatic stops that we set so that we don't run the valve stem into the grinding wheel. If we run it into the grinding wheel, we put a mark around here, that's a weak spot where it could break. So we want to ensure that it doesn't touch that. Now on a Warren valve, we want to reface it. Now what we have to pay attention to is the margin. So the manufacturer will give you a specification of what the margin is allowed to be. If it falls under that, then you have to replace the valve. When we're taking a look at the top, the stem, as the rocker moves on this or the valve bridge, it may wear this out. So we want to resurface this, and it's all done on the same machine. So we put it on there and we run the machine and we just take a little bit off to recondition the surface. We also then want to put a little chamfer on the edge of this, and it'll prevent it from splitting. If the cylinder head's been resurfaced, there's usually a stamp on the very front of the cylinder head that said that it's had 10 thousandths taken off. So always look for that. And in some cases, we may have to go with a different head gasket. Now, if we have removable valve guides, there's a special tool and an air hammer, and we remove the valve guide, and then to install the new one, there's a special tool that will only allow the valve guide to move down a certain point, and then it stops. Now we want to have this accurate because the manufacturer has it set up that, let's just say it's supposed to be 2 inches. We don't want it too far in and we don't want it too far out. So once they're all set, we can go along and measure and make sure they're where they're supposed to be. Now, if we can't replace the valve guides, there is a process to go in and straighten it and then to take and lift some material off of the inside. Now this will only last for a certain length of time, and then the cylinder head will have to be replaced. There are some cylinder heads where they can be machined right out and a replaceable insert put in. When we replace these valve inserts, again, this will pull it out. Now, you have to be able to put this in properly, otherwise it will come loose. And I have taken an engine apart where this valve insert was sitting on the bottom of the valve and was moving up and down and just destroyed the cylinder head. And I've also seen these break apart. And one of the things that you got to pay attention to, if this is broken apart, chances are it spread itself throughout the whole engine. So you have to pull every cylinder head off and check to make sure it hasn't damaged any other cylinders. The one that we had was in number 1 cylinder, and it spread debris all the way down to number 6. Again, we want to inspect for any cracks or damage. And if it is cracked, then it has to be either repaired or replaced. We also want to measure the inside of the insert to see if it's acceptable. Now, we can use this tool, but again, I would leave this up to people that do this all the time, because they have to shrink this insert and then insert it so that it can stay inside. Because again, remember the temperatures that get in there. If the tolerances aren't where they're supposed to be, that insert could come loose and damage the engine. Another thing we want to do is check for a thing called concentricity. So concentricity, we have a special tool that fits into the valve guide, and we have a dial indicator that goes around, and we check to see if it's centered. Because if it's not centered, the valve's not going to seat properly and it's going to leak. If we're doing stones or a cutter to do the valve seat, so the stones are set up and we use a drill. The cutters are done by hand, and you got to be careful. We don't want any chatter marks left. So how it's set up is we have this device here, and this is the stone here. So it's cut at the angle that we want the valve insert cut at. Underneath this is also a spring. So once we stop and pull this up, this will pop up so it doesn't leave any little marks that we don't want on the valve seat itself. Here we use a cutter. Same thing as we want to cut it by hand, but we don't want to go fast because we'll leave chatter marks. So first thing is a 45 or a 30-degree seat. Now we also want what's called an interference angle. So we can do this if we're grinding the valve seat. So for instance, we grind the valve seat at 45 degrees, we grind the valve face at 44. So we have a 1-degree interference angle here. Now, if we cut them the other way, the valve at 45 and the seat at 44 will end up with a gap, and the pressure inside could be enough to lift this valve off of its seat, and we could lose some compression. So once we've finished grinding the valve, we want to go in and we want to check to make sure that we have good contact. And what we use is a thing called Prussian blue. So here we've done our valve seat. Then we're going to do a 15-degree stone at the top and a 60-degree stone at the bottom, and that will give us our narrow margin in the valve seat for contact. So we put Prussian blue around the valve face, drop it in, don't turn it, and then lift it back up. And you should see a good contact area all the way around the head. Now, there are some people that lap valves, but they use a valve lapping compound. What this does is it laps the valve to the seat. And we have quite a wide surface area where when we use an interference angle, we have a very sharp surface area, our contact point. Once we finish that, we're going to use a sled gauge, and we're going to measure the depth of the valve head. And that's how far is it inside the head. Now, there is a specification. Manufacturers say it can't exceed X amount. And that's it for part 1 of the video.